Hello everyone. Now that we have understood what a data structure is and its usage, let's talk about how they play a critical role in designing efficient algorithms. Efficient data structures are the foundation of efficient algorithms. The way we store and organize data directly affects how quickly and efficiently we can process and retrieve the data. For instance, data structures can be used to manage information in both main memory and secondary storage, allowing us to access and modify data quickly. The primary goal of using a data structure is to organize and store data in a way that optimizes performance, both in terms of speed and memory usage. But data structures alone aren't enough. To truly solve problems effectively, we need to consider algorithms. So what is an algorithm? An algorithm is simply a step-by-step procedure or a set of instructions used to solve a specific problem or perform a task. A precise recipe for achieving a particular result, and like recipes, there are often multiple ways to achieve the same goal. Some algorithms may be more efficient than others, and that's where algorithm efficiency comes into play. Algorithm efficiency refers to how well an algorithm uses computing resources, specifically time and memory, to accomplish its task. By understanding algorithm efficiency, we can predict how fast an algorithm will run and how much memory it will require before even writing a single line of code. Why is this important? Computational complexity, which measures the efficiency of an algorithm, helps us assess how well our solution works. It allows us to compare different algorithms that solve the same problem, so we can choose the best one. An efficient algorithm saves both time and computing power, making your code more scalable and faster to run. Understanding both data structures and algorithm efficiency gives you the tools to write optimized code that performs well in real-world applications. In the next video, we will dive deeper into computational complexity and how you can measure the performance of your algorithms.